In this lesson, we're going to take a look at finding the equation of a tangent line to a curve and also the equation of the normal to some curve. And I'll just make a note of that equation of tangent and normal. So first of all, we'll just have a quick look at what we mean by a tangent line as revision. So take any curve, f of x, and I'll just do a quick sketch maybe. Okay, so we've got the y and the x-axis, and just say I have a curve that goes like this. Well, the tangent line is the line that just touches the curve in one place at one point. So it doesn't intersect the curve, it just touches it. So we'll call that the tangent. And we know from our calculus that dy dx, the first derivative, dy dx, gives us the slope of a tangent, of the tangent to our function f of x at some point. So knowing that the first derivative gives us the gradient, if we have the gradient and we have that particular point, then finding the tangent line is quite easy. So example to find the tangent line. Let's say we're asked to find the tangent and we'll have a quadratic, find the tangent of the line y equals 3x squared minus 4x plus 1. And we want to find that tangent when x equals 2. Now, it would be a good idea at this point to find the y value when x equals 2. So before we start to try and find the tangent, let's just sub in 2 and find the y value. So when x equals 2, y equals 2 times x squared, 4 minus 4 times 2 plus 1. And that equals 5. So I just see this should be 3. So it's 3 times 4 is 12, minus 4 times 2 is 8 plus 1. So it's 12 minus 8 plus 1 is 5. So the point we're looking to find the tangent at is the point 2, 5. Okay, so now we have that point and we want to find the tangent. We will find the slope of the tangent, dy dx, equals 6x minus 4. So m tangent, we'll just call it mt, we sub in equals 6 times 2 minus 4. So the slope of the tangent line is 8. We're now ready. We've got m tangent is 8, so the equation of the tangent, we can simply find it by y equals m x plus c, and m is 8x plus c. Now we'll sub the point 2, 5 into that line and calculate c. So by subbing in, we will have 5 equals 2 times 8 plus c, so that becomes 16. C equals 16 minus 5 equals 11. So c equals 11, and we need to show the final answer is y equals 8x. And did we make a c equals minus 11? Sorry, go back, correct that one. Just realized that there was an error there. So c equals positive 5 minus 16 is minus 11. So final answer, y equals 8x minus 11. Okay, so that's an example of finding an equation of a tangent line. I think I might take one from the workbook, your workbook, page 78. And if that's the same version of the workbook as mine, we could also look at finding the equation of a tangent line to other functions other than the quadratic or a cubic equation. So let's just take a second example. And let's say we want to find the equation. So we're going to find the tangent line. And it's tangent line to the curve y equals sine x at the point 0, 0. We know when x is 0, sine x is also 0. So let's take a look at that. The first derivative of sine x, dy dx, equals cosine x. So at x equals 0, cosine 0, we should know this without checking it on the calculator, cosine 0 is 1. So we have the first derivative when x equals 0 is 1. So the slope m tangent equals 1. And we put that in and find the equation of the tangent. So our tangent line y equals mx plus c, and we need to sub in the point 0, 0, 0. So simply left with c equals 0 equals 0 plus c, so c equals 0. So the equation of the tangent line will simply be y equals 1 times x plus 0. So y equals x is the tangent line. Okay, that's a second example of finding a tangent line. Now let's take a look at the normal, what exactly a normal line is. I'm going to go back and sketch a curve, or maybe I'll go back up to the other curve that we had. And I'll change the color and I'll just draw a normal line on that existing curve. So we'll go for it in red. Now the normal is the line that's perpendicular to a tangent at some point. So this line is perpendicular to the tangent, and it is called the normal. Okay, so we'll go back down and just the definition here. I'll go back to, just write in red, normal is perpendicular to tangent at some point on the curve. So if we want to find the equation of a normal, then we know from our very first lessons, we know that the slope m times m normal, if it's perpendicular, times m tangent equals -1. When two lines are perpendicular, the product of their slopes always equals -1. So we can find the slope of the tangent from finding dy dx. So mt equals dy dx, and subbing in m normal, the slope of the normal, is -1 over the slope of the tangent. And the best way to see that is by use of an example where we have to find the equation of the normal. So this time I'll take an example of a cubic equation. And we're going to find the equation of the normal. To our function f of x x cubed minus 2x squared plus 3x plus 1. And we want to find the equation of the normal at the point 1, 3. In this example, we're given the coordinates, so the x value is 1 and the y value is 3. So the first thing we're going to do is find the slope of the tangent by saying f dash x, first derivative dy dx, or f dash x equals 3x squared minus 4x plus 3. So we get the equation of the tangent when we sub in x equals 1. So the slope of the tangent mt equals 3 times 1 squared minus 4 times 1 plus 3. That gives us the gradient is equal to 2. Which means if the slope of the tangent is 2, well then the slope of the normal is -1 over 2. So change the sign and invert. So now we have the equation of the normal. We can go ahead and find, sorry, we have the slope of the normal. We can go ahead and find the equation. So we had the point, so the normal line is y equals -1 over 2x plus c. And on the normal is the point 1, 3. So we sub in 3 equals -1/2, 1 plus c. So c will equal 3 plus 1/2 is 7. 3 plus 1/2 is 7 over 2. Okay, so that can be put into our equation. Y equals -1/2 x plus 7 over 2. that answer is correct. Sometimes we're asked to show the answer in the form. If we're asked to show the answer in the form a x plus b y plus c equals 0, where a, b, and c are all integers. So if we're asked to show the final equation of the normal in this form, then what we must do is we'll multiply the whole lot across by 2. So we will end up with integers. So 2y equals minus x plus 7. And we want to rearrange it to have it in the form that we were asked for. So we'll take the x, negative x, over to the left. X plus 2y minus 7 equals 0. So this is the final answer in the form we were asked for. So that's an example of the how to find a normal line. Now at this time I would like you to go work on the worksheet that is on Moodle, the worksheet which I have here. So it's 7 questions, and I'm going to give you 25 minutes, and after 25 minutes I'll check in with you and see how everyone is doing with those questions. If there's anyone looking for help, we can check it out then. Okay, over and out, and talk in about 20.